Students, so we have completed the first two units which are based on the random experiments. Now, let us move on to the third unit which is the sampling distribution here. So, sampling distribution and estimation is completely based on the raw data here. So, what is this sampling distribution? Where we will apply this sampling distribution here. So, if you see that here, we can see the ATM machine here, right, where we have to just take the money from the machine, right. So here on the working days, definitely we used to draw the money from the ATM machines, right. Then the banks have the data with them, how much money they have collected, how much they have credited and all. But when coming to the non-working days, that is the Sundays, right, people also used to transact money through ATMs, right. Then to find the number of means what is the average money they have drawn and whether the money drawn is equal or not, they can estimate that. So to use this estimation and to find the sample here, we use the sampling distribution. So in this unit, we have a means introduction to this sampling distribution. Then we have a sampling techniques, sampling distribution and estimations here. Now what is this application of this sampling distribution? Now if you move on to the signal processing here. So generally we people used to talk through mobiles, through internets and all, right. So definitely here several people used to talk through mobiles and telephones, right. Then here whatever the signals are passing are continuous. Then there may be a disturbance of sound waves. So to minimize the disturbance of sound waves here, the continuous signals has been here sampled into the discrete signals here. Then automatically here the disturbance of the sound waves will be reduced, right. So to reduce the sound waves of the continuous to discrete, we use the sampling distribution in signal processing. Then the second application is, just now I said that here the transaction of money. So to estimate the cash drawn on the non-working days, we use the sampling distribution, because here from different time intervals we used to draw the cash, or simply we used to credit the cash also through ATMs here, right. So how much cash we have drawn, that can be estimated using this sampling distribution. So here in the first two units we have seen regarding the random experiments, means when an experiment is performed here, how to find the probability between those situations and what is the average rate of the experiment we have seen in the first two units here. But when it comes to the raw data, when we have a data with us, right, how to estimate the data, how to find the error in the data and how to analyze the data, that we are going to learn in the third unit and fourth unit, right. So to learn that here, to analyze anything, so first we have to consider the population. But it is very impossible for the researcher to consider the entire population here. So in a simple words and in an easy way, the population is defined as a collection of well-defined objects which are animate or inanimate under study, right. So for example, you can consider the entire student strength of this Vigyan college as population, right. But if you want to consider only a BTech students, right, of course we have a different courses here. We have a BTech, MTech, MBA, MCA and pharmacy, right. But when we talk about only the students of BTech, then we consider a sample of BTech students only. So the entire student strength of this college is considered as population. Only the student strength of BTech is considered as a sample. That means here sample is nothing but a subset or a small part of the population, right. But here the population size is denoted by capital N here, right. So to measure the population also we need to use some constants. So a constant used to measure the population is known as a parameter. So the population parameters, the basic parameters we consider for any research is here mu and sigma square, where mu is known as the population mean and sigma square is known as the population variance. But when we consider a small part of the population, that becomes a sample. A subset or a small part of population is known as a sample, where the sample size is denoted by small n here. So remember, you just differentiate the population size and sample size. Population size is denoted by capital N and sample size is denoted by small n here. So like the population parameters, right, we also need to measure the sample here. So to measure the constants of a sample, we use a statistic, right. So to measure the constants of the sample is known as a statistic, and the different sample statistics we consider for any analyzation of data is here sample mean x bar and sample variance small s square here, because we have a capital S square also, right? So sample mean is denoted by x bar and sample variance is denoted by small s square, right? So regarding the random experiments, for mean we use the word E of x, expectation of x. But when we come to the raw data here, regarding the sample mean, we use the symbol x bar, right? Then here you can see here, the out of this entire population, only the red colored are sample here. Okay, out of this entire population, only a small part we are considering. So the red color resembles here the sample drawn from the population. So here we can draw the sample from the population using two different techniques. They are the random sampling techniques and non-random sampling techniques. But here again the sample is classified into two types as large sample and small sample. So large sample means if the sample size is greater than 30, then it is called a large sample, and if the sample size is less than or equal to 30 is called a small sample. Now how to draw these samples from the population? So using sampling method. So the sampling method is classified into the random sampling methods and non-random sampling methods here. Random sampling method means here to draw the sample from the population we just use a continuous manner here. So the different random sampling techniques are here simple random sampling, stratified random sampling, systematic random sampling and cluster random sampling. And the other way to draw the sample from the population is here non-random sampling techniques. So the different non-random sampling techniques are convenience sampling, quota sampling, judgment sampling and snowball sampling. Now we will discuss here what is this simple random sampling, stratified, systematic and cluster random sampling, right? So here simple random sampling means if we want to select a sample from the population in a very simple manner, we select the sample. Again here we can select the sample repeatedly for many purposes, or once the sample is selected for one purpose, then we cannot use the sample for multiple purpose here. So the simple random sampling is again classified into two types as with replacement and without replacement. With replacement means multiply we can use the same sample for different purposes. But whereas without replacement means once we have used it for one purpose, then the sample cannot be repeated here, right? So here if I want to pick out some balls from a box here, right? So if I have we have the different colors of balls are there, red, green, blue and black color balls are there, right? So if just I put a hand in the box, I am getting all red balls, no problem, I can select that, right? If it is a combination of red, blue, black, green, yellow, no problem, it is a simple random sampling with replacement. But here when I am just putting a hand in the box and I am getting all the red with a combination of yellow, that means red balls are repeating here, then I can't consider for without replacement. Without replacement means if one red ball is selected, it can't be selected for second time. So another yellow ball, right, then blue ball one and black ball, green ball, like that. So that is without replacement. But to draw the sample from the population with replacement, here the formula is capital N power small n here, where capital N is the population size and small n is the sample size here. And to draw the sample without replacement from the population, the formula is here capital N C small n, means we have to follow the combinations here. So you can see the example also, we have a different color of balls are there here, right? So just I am considering two different boxes. So green color is repeated twice and pink color is repeated only once, so that is with replacement. But we see in the upper box here, right, there we have three different colors, that is the without replacement. If one color we have chosen means we are not choosing the color for second time here, so that is without replacement. Okay, so in a simple manner we have to select the sample. There is no particular criteria for selecting the sample from the population. Then move on to the second sampling technique, random sampling, that is stratified random sampling. So when the population is very heterogeneous, right, then also we need to consider a sample from the population. When it is very heterogeneous, we will divide the population, heterogeneous population, into different subgroups. So these subgroups are known as strata here, right? Then again from each strata we will draw some elements we will draw some samples from the population in a simple manner, then that is called the stratum, right? So here you can see the example. Here we have a blue, red and green color as a population. So it is highly impossible for a researcher to select the sample when it is very heterogeneous, right? Then they are selecting red as one strata, green as one strata and blue as one strata here. Then again from blue we are considering some elements, from green some elements and from red some elements. Then it constitutes a stratified sample, right? For example here, I just want to carry a research problem on the psychology of students here, right? So here we have a different streams of students. We have a BTech students, we have MTech students, MBA students and MCA students. So here BTech students means they are undergraduate, right? And MTech, MBA, MCA means they are postgraduate. So means lot of difference will be there in their attitude and their behavior, right? But I want to carry the research of psychology on students here. So just simply I will pick up some students from BTech, from MBA, from MTech, like that, right? Then here the student psychology is different from course to course and from age to age. So I can divide that age into different intervals or the courses into different groups here. Then from the different groups here I can select the sample, that is the stratified random sampling. So this stratified random sampling is applicable only when the population is very heterogeneous. Now coming to the systematic random sampling. So according to some criteria and according to some rules only we have to select a sample from the population, right? So if I want some student volunteers for one particular program here, then definitely here we will see the students who are very good at academics, who are very regular to college and who are good at discipline. Means according to some rules we are selecting a sample from the population, right? So here if you see here we have a population like this, right? So every third member in that line I am selecting the sample, means I am following some strategy for that, right? So to select a sample from the population using systematic manner means according to some criteria I have to select the sample here. Then the last random sampling technique is cluster random sampling. So here this cluster random sampling is mainly useful for the geographical purposes here, right? So when the population is very wide, large enough, then we use this cluster random sampling, right? Of course here a homogeneity is there, but again in the homogeneity we occur the means the heterogeneous occurs here. Then we will select the different parts of this heterogeneous and again in a homogeneous way we select the sample here, right? So we have a different sort of people here. So we will just classify those sort of people into different groups, that is again heterogeneity. Then again from those we will select a sample in a simple random manner. So in cluster random sampling here we use the simple random sampling and as well as the stratified random sampling here, right? Means stratified means when the population is very heterogeneous, then we use that, right? So here also all sort of people will be there in this cluster random sampling, right? So from that again we just here select that means we will divide that homogeneous into different heterogeneous. Then again from each heterogeneous we will select the sample here. So that's about the cluster random sampling technique, right? Then coming to the non-random sampling techniques. Non-random sampling techniques is classified into convenience, judgment, then quota sampling and snowball sampling here. So the first one is here convenience sampling. So according to the convenience of the researcher they can select the sample here, right? So if you see the shopping mall here, if one wants to know the attitude of the customer, so at the entrance of the shopping mall only, right, the researcher will ask the questions to the customer. That is a convenient way to select the sample instead of simply distributing the feedback cards to the customers, right? So they can stand at the entrance of the shopping mall and they can answer those respondents here, right? That is a convenient way. Means here the researcher will select the most convenient way to get the sample from the population, right? Then the second non-random sampling technique is here quota sampling. Quota sampling means here your research problem may consist of different age groups, right? Like here, if let us consider here we have the college strength of some 5,000 students here. So out of those 5,000 students, right, we can consider some 3,000 girls and 2,000 boys. So whenever we are selecting a sample, right, quota wise we have to select the sample. So among 3000 girls we have to pick up some 100 girls, and among 2000 boys we have to pick up some 100 boys, like that. So according to quota we have to, means according to different parts of that sample we have to select a sample. So that's why it is quota sampling, right? Then the last the third non-random sampling technique is here judgment sampling. So this judgment sampling is also known as purposive sampling technique, which is completely a biased sampling technique, we can say. So according to the researcher convenience, right, even though that sample does not desire all the characteristics of the research problem, right, but the researcher is selecting the sample. So you can see the recruitment process here, right? Even though the candidates are very extraordinary for that particular position of a company, right, but due to some recommendation here, the recruiter is forced to take some person who is not at all desiring all the characteristics of that position. So that is the judgment sampling here. So completely it is a biased sampling, right? Then the last one is the snowball sampling technique. So here in this snowball sampling technique, when the population is very large, they have to collect the sample. So here in this snowball sampling technique, the researcher appoints some enumerators. Enumerators means here, if we consider the student strength of this college here, we have a BTech students, we have a PG students, right? So I will select some person to select the sample from the BTech and to select the sample from the MTech. Two persons I will select here, right? So the one person will go to the BTech sample and he will collect the samples from that. So he is called the enumerator. And another person wants to select the sample from the PG students, so he is another enumerator. Means here directly the researcher is not selecting the sample. The researcher is appointing the enumerators to select the sample again from the different regions here, right? So here the first enumerator again can appoint some two more enumerators to select the sample. And here also the second enumerator can appoint two more enumerators to select the sample here. That means a work has been assigned from the researcher to two enumerators, and again from the two enumerators to different enumerators to select a sample from the population when it is a very wide population, right? So this is about the different sampling techniques used to select a sample from the population, right? So here remember here this unit is useful to just categorize the continuous signals to the discrete signals here, right, and also to estimate the data, right? So let us go to the next class. In the next class here we will discuss the what is the standard error in the sample. Okay.